assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this example, we have this closed conductive loop here, where a top piece of this loop can be rotated around by a crank to actually change the shape of the loop. Now it's all hooked up to a resistor and it's sitting in a constant uniform magnetic field. So we know that if we rotate this top piece of the loop here around, we're going to change the shape of our loop, thus changing the total area, which means we'll have a change in flux, which means we will induce an EMF in our circuit, and which finally means we will induce a current through our circuit. And what we want to know is what direction is our current going, specifically which side of our resistor is positive and which side is negative. So you can imagine if we started turning this loop here, imagine that we turned it a quarter of a revolution at first. It would be pointing straight up into or out of the page, and we just have a square loop like this. And if we did it another half revolution, we can see that the shape of the loop would look something like this, where our circle now juts inward, like this. So we can see that the total area of our loop is going down, right? And if that's the case, we know that we have a decreasing flux. So let's write down what we know so far, because we're going to use Lenz's law to determine the direction of our induced current here. So we know that the flux is decreasing, and we know that the B field is into the page. So if the flux is decreasing into the page, we want to create a field that counteracts that, which means that we will want to create a current that produces a magnetic field that is also into the page. So remember, if flux is decreasing, we're going to want to create a current that goes in the same, that creates a field that goes in the same direction as the direction of our flux already. And if it's increasing, then it's the opposite. So we want a current that makes our field go into the page. So by the right-hand rule, if you point your thumb in the direction of the field you want to create and curl your fingers around in the direction of current, we should have that the current is going clockwise like this. You point your thumb into the page, which means that the positive side of the resistor is here and the negative side of the resistor is here. So as our final answer, we can say that the right side is positive.